Hi, today we're going to be working with Trig again. Yesterday, or the last time we had a video, we were finding missing sides, and today we're going to focus on finding missing angles. So if you don't have your calculator out with you, you want to go ahead and grab that. All right, so let's go ahead and get started. So first of all, we are going to be rounding our angles to the nearest degree, so that's going to be the nearest whole number today. So we're just going to jump right on in. So we've been doing a lot with trig and right triangles. So we've got our first right triangle over here, and we know this side here is 8 and this guy is 17. We don't know this side, and we don't know either one of those angles. So a couple days ago, we actually worked on writing trig functions if we don't know an angle. Today we're going to be using that again, as well as actually solving that. So if our goal here is to find the measure of angle A, the first thing we're going to do is ask ourselves, can we use the Pythagorean theorem? Well, in this problem, we absolutely can use the Pythagorean theorem because we know two sides of our right triangle, but knowing two sides of our right triangle, Pythagorean theorem only finds another side, it doesn't find an angle. So although we can use the Pythagorean theorem here, it's not going to help us find angle A. If we were going to use the Pythagorean theorem to find this missing side, because sometimes we'll need to do that, we're going to have 8 squared plus b squared equals 17 squared. So 64 plus b equals 289. Sorry, b squared. b squared equals 225. So our missing side is 15. Okay. So that didn't really help us find angle A, so what else can we try to figure out? What is our reference angle? Well, if we're trying to find angle A, that means we want Bob to be standing at angle A, so A is our reference angle. Where Bob stands. I guess we can capitalize his name. Because that's what we want to find. We want to find angle A. So next thing we need to do is, now we know our reference angle, we know where we're standing, we actually found this side to be 15. We need to figure out, if we're going to use trig to help us, which trig function should we use? So if we remember SOHCAHTOA, so that way we don't have to keep remembering which sides, I'm going to go ahead and write it down. In order to figure out SOHCAHTOA, or which trig function to use, we need to label our sides. So if Bob is standing right here, then the 8 is the opposite side, 17 is the hypotenuse, and the missing side we had a minute ago, but now we know because we found it using the Pythagorean theorem, is our adjacent side. Now if we only knew 8 and 17, if we didn't take the time to use 15, then we would have to choose a very specific trig function. So let's say this wasn't here, we would have to use sine, because that is opposite over hypotenuse. But because we found 15, we can actually use any of our trig functions, because we could use opposite and hypotenuse, but since we know 15, we could use adjacent and hypotenuse, so we could use the cosine, or we could use opposite and adjacent and do tangent. So if you know all three sides, you can use whichever trig function you want. I'm going to go ahead and just use sine. So sine of where Bob is standing, that's what we're going to use because we have the opposite and the hypotenuse that were given to us, okay? So how do we find the measure of angle A? Well, first we're going to plug in what we know. So sine of A, we don't know A. If I'm going to use opposite and hypotenuse, it'll be 8 over 17. All right, so here's where it gets a little bit tricky. So maybe you'll remember this from last semester. A lot of times when we look at this, we'll see this as sine of A means sine times A, but it doesn't mean multiplication. They're just kind of next to each other. If this is not multiplication, then we cannot divide by the sine of A. So we cannot do that. We can only use division if it's multiplication that's happening in our problem. But when we have sine of A, it is not multiplication. So it's kind of similar to the square root of 10. Like, we're taking the square root of 10. It's not the square root times 10. It's the square root of 10. So this is not sine times A. It's the sine of A. So because it's not multiplication, we cannot use division. But we are going to use the inverse function of sine. If this were multiplication, the inverse would be division, and so we'd use division. But this is not multiplication. Since this is the sine function, we're going to use the inverse of sine. So you may remember this from the regular school year. Above the sine button, there's this sin with a -1 behind it. That is the inverse function. So in order to cancel out sine, we have to use the sine inverse, which is the sine with a little -1. So on this side, we are going to, it's going to look like multiplication, but we're actually going to take the inverse of sine. And notice that I'm writing this sine of a in parentheses, and I'm taking the inverse of the entire thing. Now, whatever we do to one side, just like in any old equation, we have to do to the other. Now, the sine inverse is supposed to go in the front, not behind it, in the front, because it's not multiplication, so it can't just be written wherever you want to. Now, sometimes it's a hard squeeze, so you don't have to write it in this line. You can actually write it down here. Sine inverse of the sine of a equals sine inverse of 8/17. So that way it's a little bit more clear. So the purpose of this is the sine inverse and the sine, because they're inverses, they will cancel each other out, and it'll leave you just a. And on this side, these are not inverses, but this is what will get typed into our calculator. All right, so depending on what kind of calculator you have, the forward ones or the backward ones, it will depend on how you type it in. So if you have one of those forward calculators where you can see everything you're typing as you're typing it, then you're going to type in exactly what you see here. So to get to the sine inverse, you're going to have to hit second and then the sine button to get to that inverse. So second sine, and then you can see on your calculators, got sine with a -1, and then you'll type in 8 divided by 17. So 8 divided by 17. So if you type that in and you get 28.07, then your calculator is a forward calculator and you're going to type it the exact way that you see it. Now, a couple things. We are going to round to the nearest degree, which is the nearest whole number. So then angle A is going to be approximately. We look at the tenths place, that's a 0, so it tells us to stay at 28 degrees. Now, if you have a backward calculator, this is where it gets a little tricky, okay? So this was for your forward calculator. For your backward calculator, you actually have to do the division first. So you're going to have to do 8 divided by 17, hit equals, and then do second sine. And then probably hit equals one more time. So if you have a backward calculator, you have to do the division first, hit equals, and then do second sine and hit equals. So either way, you should end up with 28 degrees. So if you can't get 28 degrees, just like reach out to me. We have some Zoom FaceTime hours that I can just show you face to face in probably like 1 minute. All right, so we are going to continue working with that going forward. So let's look at our next example. So in this problem, we're going to find angle A again, which means that's going to be our reference angle. So I'm going to set Bob there. Now, I don't currently know this side, but because I have two sides, I can use the Pythagorean theorem to find my third side if I want to. I'm just looking for angle A though, which means I don't need to. But if I do find this side, then I'll have my choice of any one of these trig functions. If I don't find this side, then I have to choose the exact specific one that I need. So in order to do that, I'm going to have to label my sides. So my missing side is my opposite side, 13 is adjacent, 20 is the hypotenuse. So I don't know anything about my opposite side, so adjacent and hypotenuse is cosine. So I'm going to do the cosine of where Bob is standing, A, 13/20. Okay, so very similarly to what we did up here, in order to cancel out sine, we use the sine inverse. So in order to cancel out cosine, I'm going to use the cosine inverse. So I'm going to inverse both sides. So cosine inverse of cosine and cosine inverse of 13/20. So our cosines will cancel each other out, and A will just be whatever cosine inverse of 13/20 is. All right, so depending on what kind of calculator you have, this is where we're going to have to figure out what order to type things in. So if you have the forward calculator, then you're just going to type in second cosine to get the inverse. And then we've got 13 divided by 20. So if you typed it in correctly, angle A should equal, we're going to round to the nearest whole number. So the 4 here, then the tens place tells us to keep it at 49. So angle A is 49 degrees. If you have a backward calculator, then you're going to have to do the division first. 13 divided by 20, hit equals, and then do second cosine, and it should still spit out 49 degrees. All right, next example. I want you to pause the video and take a second and see if you can get this guy figured out. Now, we're going to do two things this time. We're going to find the measure of angle A, and we're going to find the measure of angle B. I want you to use two different trig functions to do that, which means once you set Bob the first time, you're going to have to move Bob for the second time. All right, if I set Bob here, opposite is my 12, hypotenuse is my 17. Opposite and hypotenuse is sine. So the sine of A is equal to 12 over 17. I'm going to use the inverse, so sine inverse of the sine and sine inverse of 12 over 17. So my inverse and my sine will cancel, and I'm going to go ahead and type in sine inverse of 12 over 17. So second sine 12 over 17. So this, the 9 is going to tell me to round that up to 45. All right, now we're going to do a second trig function for B. So Bob will have to move. Does that change anything? Will the hypotenuse change? Nope, hypotenuse is always across from 90. Will the opposite side change? Yep, now the blank side is our opposite side, which makes the 12 the adjacent side. So how does that affect our trig function choice? So now we're going to use cosine. So cosine of B, because Bob moved to B, 12 over 17. Now you'll notice that we're using the exact same two numbers, we're just using a different trig function this time. So when I solve this by doing the inverse, cosines will cancel out, and B equals the cosine inverse of 12 over 17. So if I go ahead and plug that into my calculator, cosine inverse, so second cosine 12 over 17, the 0 tells us to keep it, so B equals 45 degrees. All right, so this is really important. How do we know if these numbers make sense? Oh, I'm sorry, it must have been out of the frame there. Is it possible for this angle to be 45 degrees and this angle to be 45 degrees? Well, absolutely. That actually makes it like a 45, 45, 90 triangle, right? So when we are finding angle measurements, if I know angle A on this first one was 49, I can write a second trig function to find C. Or if I'm feeling really confident that A is right, how could we find C? Well, it's a triangle, so couldn't we do 180 minus 90 minus 49? So 180 minus 90 minus 49. So angle C should be 41 degrees, right? So if we use one trig function to find an angle, then we can actually just use subtraction to find the other angle. Now the only thing I will caution you on is if this is not right, and then you use subtraction to find this angle, they will both be incorrect. But if you use trig to find your first angle, and it's wrong, but you use trig to find your second angle, you still have a chance to get that one correct. So if you're feeling confident on your first angle, feel free to use subtraction. But if you're like, oh, I'm not sure if that's right, then I would use two different trig functions to find those. All right, just a couple more left here. The next thing we're going to do, these are a little bit different. We are going to solve the triangles. So what does that mean to solve the triangle? That's kind of vague. all it means is find all of the missing sides and all of the missing angles that are in your triangle. So in our picture, our missing sides and angles are x, y, and z. So x is the hypotenuse, y and z are just the missing angles. So how do we find x? There's only one side there, so let's start with sides. Well, we have a right triangle, and we know two sides of that right triangle, so we're going to use the Pythagorean theorem to find it. So go ahead and pause the video, use the Pythagorean theorem, and find out how long AC is. How big is x? All right, you can see that I just did the work here for my Pythagorean theorem. 12 and 18 were my legs, so they're on this side by itself. So when I solved that, I got the square root of 468, which is approximately 21.6. When we when we find sides, we're gonna round those to the nearest tenth, so that's why I left my decimal place. All right, so now let's set up two different trig functions. I'm going to do one for y and one for z. After we find y, then we could just use subtraction to find z, but I'm going to use a trig function just because I'm trying to get practice with that since we're just learning how to do that. So again, pause the video, set up your trig function, and see if you can solve for y. We'll start with y and get that correct. All right, so I labeled Bob in my picture, and then I labeled my sides opposite, adjacent, and hypotenuse. Now we just found the hypotenuse, so we could use any trig function we wanted. I'm actually not going to use that though, because this is a decimal, it's an approximate answer. And if I use an approximate answer, it's gonna throw my other answers off just a tad. So I'm gonna just use these two sides that I already have in my picture. So that's gonna be the tangent. And now I can call this angle A or I can call it Y, either one, they're representing the same thing. So the tangent of A is equal to 12 over 18. So we're going to inverse both of these sides. So I'm going to inverse this side and I'm going to inverse this side. Notice my inverse is going in front of my fraction. So my tangents will cancel and A equals, so it's 33.69, so the 6 is going to tell us to go up to 34. Now, if we're feeling confident to find z, which is angle C, we can just do 180 minus 90 minus 34, and that should give us this angle. But since this is our first day of doing the angle measurements, let's go ahead and just practice finding z with another trig function. So pause the video, set up a trig function, and solve it for z. Okay, so I chose the tangent function again because I used the opposite and adjacent, but Bob would have moved, making this my opposite side and this my adjacent side, which is why I have 18 over 12 instead of 12 over 18 like we had in the first one. So I inversed both sides and got 56.31, which I said was approximately 56 degrees. So if we look at this, 34, 56, and 90, 34 plus 56 plus 90 should equal 180 if those are representing all of the angles in our triangle. And you can see that they do, which means we know for sure that we got both of these correct. All right, example 4, our last one here. I'm going to have you pause the video and see if you can find x, y, and z all on your own. Okay, so you can see my work here for z. Z is a side, so I used the Pythagorean theorem because it's a right triangle and I knew two sides. So I ended up with the square root of 164, which is approximately 12.8. So that side is considerably smaller than those two sides. So if we just kind of think about that, that means x should be the smallest angle because it is across from the smallest side. So when we do this work, we want to make sure that x is actually the smallest angle. All right, so then I did x, so I put Bob in my picture. I labeled my sides opposite, adjacent, hypotenuse. I used the 40 and the 42. I didn't want to use the 12.8 because it was rounded, so I just used these two numbers that I already knew for sure. So I chose the cosine function. I inversed both sides and got 17.75, which is approximately 18 degrees. So does that make sense? Well, 18 is pretty small angle measurement, but 12.8 is pretty small in comparison to 40 and 42, so that does kind of make some logical sense. All right, so when we find y, it definitely should be bigger than 18 because it's in the side is the medium-sized side, so this should be the medium-sized angle. So if I want to find y, I have two options. If I'm feeling really confident that this is right, I could do 180 minus 90 minus 18, and that should give me my answer. So 180 minus 90 minus 18, so I got 72 degrees. Now, this will only be right if 18 was right, because we're using that 18 in this problem. So I'm just going to do a backup method. I'm going to use another trig function. So in order to use another trig function, I've got to move Bob. That changes my opposite and my adjacent sides. So now adjacent is here, opposite is here. So I'm going to use the sine function. So the sine of A. Now I could also put the sine of y there. That's okay. 40 over 42. I'm going to have to inverse both sides. So sine inverse of 40 over 42. So A should equal, hopefully 72, right? Sine inverse 40 over 42. 72.24, which is approximately 72 degrees. So that is Y. How'd you do? Did you get them all by yourself? If you did, fantastic. If not, and you have more questions, please reach out to me. You can email me, send me a comment in Canvas, or come to the Zoom office hours from 10 to 11. Otherwise, have a fantastic day.